Hello class, welcome to today's lesson. It's all about Argand diagrams, which is a geometric representation of complex numbers. So let's get into it. So if I was to add two complex numbers together, you can see Z1 and Z2 here. That's just going to be equal to the sum of the real components to make up the new real component and the sum of the imaginary components to make up the new imaginary component. So therefore, the real and the imaginary components of a complex number do not interact under addition. So in other words, there's no non-zero multiple of the real component of the complex number to make up an imaginary number, and vice versa. So this means that we can see them as different dimensions. And therefore, any complex number has two dimensions, which means that the set of complex numbers is represented by a plane or a 2D surface. An Argand diagram is a representation of complex numbers on a plane. So you can see this number Z here, okay, A plus BI. Well, the way we represent that number on the Argand diagram is that we look at the horizontal axis, like the real axis in the Cartesian plane, as the real component, and the vertical line as the imaginary component. So Z equals to A plus BI now can be represented with A in the real direction and B in the imaginary direction, and therefore we have that point here. This is Z equals A plus BI. So let's just do a couple of quick examples to see what I mean. So in example 10, you have this diagram with these points on here, and we need to say what number is there. All right, so let's just do this quickly. A is clearly 2 across in the real line and up 1, 2, 3 in the imaginary line. So therefore, A has to be 2 for its real component plus 3i for the imaginary component. B has no real component. It just has the imaginary component of 1, 2, 3, 4. Okay, so B is 4i. There's no point writing 0 plus 4i, it's just 4i. C, similarly, has no imaginary component. It's on the real line, and that is minus 5. And there's, over here, and there's no point writing plus 0i, it's just minus 5. All right, D next has minus 1 in the real direction and plus 1 in the imaginary direction. E is minus 5 in the real direction and minus 2 in the imaginary direction. So that's minus 2i. And F, the final one, has 1 in the real direction and 1, 2, 3, 4. 1, 2, 3, sorry. So 1 minus 3i gives me F. And in example 11, we're going to go the other way. So we've been given some numbers and we're going to add them to this diagram, okay? So number 2 is just on the real number line. So 1, 2, here we go. So that's number 2. And minus 3i, well, that's just on the imaginary axis. So that is minus 1, 2, 3. So we've got minus 3i there. And then 2 plus I is 1, 2 plus I. So we go up 1 here. So we've got 2 plus I. Hopefully that writing's big enough. Of course, you can check the OneNote later on. Okay. And the final one, which I didn't write the bracket on properly before, is here, is minus 2 times 2 plus 3i. So you could draw 2 plus 3i, which is where our A is, and then multiply it by minus 2. So we're going to see later on how to do this, okay? But just for now, you can expand the brackets, so that's obviously minus 4, minus 6, I. So we'll go 1, 2, 3. That's minus 4 there in the real direction, And then we've got to go minus 6. 1, 2, 3, 4, 5. It's about 6 there. So here we go. So you could write that as minus 4 minus 6i, or minus 2 times 2 plus 3i. And you might want to think about how we're going to do that later on.